Welcome to The Deep Dive. Today, we're plunging into something, well, really quite unique. A tradition woven so deeply into the fabric of Japan, but honestly, often tricky for outsiders to really grasp.
Definitely.
We're talking about Shinto, often called Japan's indigenous spiritual path.
Yeah, and it's a tradition that's very much alive. You see it in daily life, big festivals, but it doesn't fit neatly into boxes like maybe some other world religions.
Right. It feels ancient, but also kind of fluid and very tied to specific places.
Incredibly place-based,
Yeah, absolutely. And to help us navigate this fascinating area, we've done our homework. We've taken a deep dive into some great source materials. Specifically, excerpts from the Wikipedia article on Shinto. And our mission, as always, is to cut through the detail and pull out the really important nuggets, the key insights, to help you quickly get a solid handle on what Shinto is all about.
So we're going to look at that core concept, Kami. We'll explore the incredible diversity of practices you might see.
From the big shrines to, like, little altars and homes.
Exactly. And trace its history, which is complex, evolving, lots of twists and turns.
And I think what's so interesting right from the get-go is this idea that Shinto isn't really about fixed beliefs or doctrines you have to sign up for. The source material really emphasizes it's more about, well, things that should be done.
Right. A focus on ritual, on practice, on maintaining harmony.
It feels very practical almost, and totally inseparable from Japanese culture.
That focus on action, on integration, that's absolutely key. Because unlike traditions maybe centered on one founder or one specific holy book, the material shows Shinto is remarkably diverse.
Yeah.
Scholars even argue about when it really became distinct enough to be called a religion.
That slipperiness, definition-wise, that's one of the first things that jumped out at me, too. Some scholars just see it as basically belief in kami, those supernatural entities.
But others, like Helen Hardiker has mentioned, define it more broadly, including the doctrines, institutions, rituals, communal life, all based on kami worship.
And what's really insightful is how many practitioners see it. They might not even say they're Shintoist.
Right. For some, it's more like a way, a custom. Do or michi are the terms used, which partly reflects its history, its connection to the Japanese state before, the modern separation of religion and state happened.
It really drives home that we're not talking about some single unified church structure here. The material makes distinctions: popular Shinto, domestic Shinto, shrine Shinto, and historically that very controversial state Shinto. It's more like a spectrum.
Think of it less like one building, one sign, and more like a huge landscape. Lots of different paths, different gardens, but all rooted in the same ground. Reverence for kami.
And the name itself, Shinto.
Yeah, it means the way of the kami. Comes from Chinese characters shin for spirit, tu for way.
But even that name Shinto wasn't always the main term, was it?
No, apparently it only became common relatively recently, like early 20th century, partly to make a clear distinction between these indigenous practices and Buddhism.
Okay, which brings us right to the absolute core, these kami.
Yes. The source describes Shinto as polytheistic and animistic. It all revolves around kami.
And this I found fascinating. Translating kami into English is really, really hard.
It is.
Words like God or spirit, they just don't quite cut it. The material practically begs you not to just do a simple translation because the concept is so fluid.
Fluid is the perfect word. Kami aren't like, say, the transcendent, all-powerful God in monotheism. They're often described more as the power or essence you find in things. Phenomena that inspire awe, wonder, reverence.
Kitagawa compared it to Western ideas of the sacred, the numinous, but fundamentally different.
Fundamentally different, yes. And critically, kami are believed to inhabit, well, potentially everything.
Living things, dead things, natural forces, mountains, rivers, wind, rain.
Even abstract concepts or specific actions. As Nilson's quoted, Shinto sees the actual phenomena of the world itself as being essentially divine.
That's the animist at heart right there.
Exactly. And what makes them even more different is that kami aren't necessarily seen as all-powerful, all-knowing, or immortal.
So they can be good, helpful.
Benevolent. But also capricious, destructive.
Yeah.
They can even cause misfortune shinbatsu if they're ignored or disrespected.
Which explains why the relationship between humans and kami is so central. It's about cultivating harmony, showing respect,
seeking blessings, appeasing negativity. It's this reciprocal balance. Humans, kami, nature.
And while kami might be linked to specific places,
they aren't strictly stuck there. The physical object or place where a kami is thought to reside is called a shintai.
And at shrines, these are often things like mirrors or swords, kept hidden, right? Not meant to be seen.
Correct. Now, here's the bit that really, as you said, blows your mind from the source material.
Yeah.
Kamis are not considered metaphysically different from humans.
Meaning?
Meaning, it explicitly says humans can become kami.
Wow. Okay. That's huge.
It's profound. Ancestors, national heroes, people who embodied extraordinary qualities they can be venerated after death, become kami.
Like Emperor Ujin becoming the war kami Hachiman.
Precisely. And even living humans. Sometimes the emperor in certain historical periods, or leaders of some sects, were viewed as kami, or hitogami.
That just completely reframes the whole idea of the divine. It's not just out there, it's immanent. It's something potentially within the human sphere.
And this perspective shapes the creation myths, too. The ones in early texts like the Kojiki and Nihon Shoki.
Those 8th century writings.
Yeah. Now, they were influenced by Chinese thought, but they tell stories of these primordial kami created the Japanese islands and, importantly, establishing the imperial line through the sun kami, Amaterasu.
Which was pretty convenient for the early elites trying to legitimize their rule.
Absolutely.
Yeah.
And while these myths talk about different realms, a heavenly plane, our human world and underworld modern Shinto mostly focuses right here, on this life, the phenomenal world we live in.
Okay.
There's belief in a soul or spirit, mitama or tamashi, that might eventually join the family kami, maybe after like 33 years.
Yeah.
But the big emphasis isn't on a detailed afterlife.
And that's often where Buddhist beliefs kind of slot in for many Japanese people, right? The ones about ending suffering, reincarnation, etc.
Exactly. They often coexist. Many people engage with both traditions for different aspects of life and death.
So if the focus is on this world and on maintaining harmony, what are the key principles guiding how people should act? Which brings us, I guess, to purity.
Yes, this source really underscores this. Avoiding kigori, which is pollution or defilement, and pursuing harai, purification, is absolutely paramount.
And this isn't just some abstract religious idea, is it? It seems to seep into everyday Japanese culture.
Oh, completely. From bathing rituals to how carefully food or spaces are prepared, it's pervasive.
The materialist things that cause this kigor, death, illness, certain bodily fluids, but also actions seen as morally wrong or disrupting harmony, like incest or even witchcraft.
And this is crucial, kigor isn't seen as like a permanent stain or inherent sin.
Humans are fundamentally pure.
Fundamentally pure, yes. Pollution is temporary. It can be cleansed through various purification rites.
Like misogi, using water or salt, sometimes even like full immersion in the sea.
Yeah, that's an ancient practice linked to the myth of Izanagi purifying himself after visiting the underworld.
Or you might see a priest waving a haregushi wand. That's another common purification method.
And this focus on purity links directly to ethics, even without a strict list of commandments like you might find elsewhere.
Right. Goodness comes from practicing sincerity, makoto, honesty, tadashi, working diligently, showing gratitude.
And the ideal state is described as kanagar, living according to the natural flow, the way of the kami, which is believed to embody wa, or benign harmony.
So disrupting that harmony is bad. Contributing to it is good. Simple in principle, profound in practice.
This emphasis on harmony, on the collective good, it has historically meant individual desires often took a backseat to the group, right?
And it also connects to that concept of Saisichi, the historical union of religious and political authority, which has had a complicated legacy.
And this leads us into some of the more sensitive historical points mentioned in the source material. Yeah. Particularly in the modern era, leading up to and during World War II, Shinto became deeply intertwined with nationalism and state power.
Leading to what's known as state Shinto.
Exactly. And the source points out that this period and its legacy has caused suspicion, both within Japan and from neighboring countries.
The Yasukuni Shrine is mentioned specifically.
Yes, because it enshrines Japan's war dead, including some convicted Class A war criminals from WWII. Official visits there by Japanese politicians consistently draw condemnation, especially from China and Korea. The material just reports this factually, as a significant point of ongoing tension.
Right. It's presented simply as a factual consequence of that history and the shrine's specific enshrinement choices. It also notes ethical debates priests face today, like balancing local traditions with these broader national or international sensitivities.
Yeah, it's not simple.
Yeah.
On a different note, the source mentions a more recent trend trying to portray Shinto as this inherently eco-conscious, nature-loving spirituality.
Kind of linking it to modern environmentalism.
Right. Though it also acknowledges that some critics view this interpretation with, let's say, caution.
Okay, stepping back from the history for a moment, let's talk about where Shinto really comes alive for most people, the practices. As I said, it's about things that should be done.
And these practices are just so deeply embedded in Japanese life, it's often hard to draw a line between Shinto ritual and just general Japanese custom.
They really form a core part of the cultural orientation.
Definitely. Public worship mainly happens at genja, shrines, literally kami places.
And the source says there are around 100,000 public shrines across Japan.
About that, yeah. An incredible number.
And a shrine isn't just one building.
No, it's usually a complex. You'll typically have a honden,
Yeah.
where the kami itself resides, containing that hidden goshintai,
Right.
and then a heiden, a hall for worship,
And they're often built into natural settings, right? Groves, mountainsides.
emphasizing that connection to the natural world where the kami dwells. Very intentional.
And the entrance. Everyone knows the torii gate, that distinct red or sometimes wooden archway.
Iconic. Passing under it is symbolic. You're moving from the everyday world into the sacred space of the kami.
The material also notes how important it is to keep shrines clean, maintained.
And that ancient practice of periodically rebuilding shrines, like the famous Ai's Grand Shrine does every 20 years, that was historically about ensuring purity, revitalizing the sacred energy.
Who oversees these shrines? The priests are called kanushi.
Kanushi, right, meaning proprietor of kami. Historically, it was often a hereditary role. And while women were priests way back, they were largely excluded for a long time until after World War II. Now, maybe about 10% are female.
And they're often assisted by miko, shrine maidens.
Yes, typically unmarried women. They have important roles, including performing sacred kagura music and dance. That's done to entertain and pacify the kami.
So what does a typical shrine visit, a senki, involve?
Well, usually you make an offering, maybe ring a bell to get the kami's attention.
Then bow, clap twice the kashi wade, and pray silently.
Right, and the source mentions something interesting here. People aren't necessarily praying to a specific named kami. They might just be connecting with the general presence, the energy of the kami of that particular place.
Interesting.
Rituals almost always start with purification, harai, like washing your hands and mouth at the Temizia fountain near the entrance.
Or a priest waving that haragushi wand.
Exactly. Then come the spoken petitions, the norito, and offerings, hubei, are key.
Historically, that could be food, cloth, weapons, even horses.
Apparently. Today, lay visitors usually offer money. Priests offer symbolic things. Food, drink, especially sake, maybe branches from the sacred sakaki tree.
And the source makes a point. Animal sacrifices are not part of Shinto.
Absolutely not. Shedding blood is considered polluting kegare.
Sake, the rice wine, seems really important, though.
Very common offering. And drinking some of that consecrated sake omiki after the ritual is like sharing a meal with the kami, a kind of communion. Major rituals might end with a feast, a naurai.
Beyond the shrine itself, Shinto is present in daily life too, right? Through kamidana.
Yes, home shrines, literally kami shelves. They became really widespread in the Meiji era. You find them in many Japanese homes, offices, even shops.
And it's common for a household to also have a Buddhist altar, a butsudan, for the ancestors.
Very common. The kamidana usually holds a charm from a major shrine, like Ise, maybe one from the local shrine too, and represents the family's own tutelary kami. People make small daily offerings, rice, salt, water.
What about other popular practices, like those wooden plaques, Yema?
Ah, yes, where people write wishes and hang them up at the shrine for the kami to read.
And divination, like the paper fortunes, omikuji?
And if you get a bad one, the custom is to tie it to a tree or a special frame there, kind of leaving the bad luck behind.
Or rejecting the prediction, maybe? And amulets seem huge, too.
Oh, everywhere. Ofuda for general protection, and the little omamori charm bags for specific things, safe travel, passing exams, finding love, you name it.
Festivals, matsuri, sound like the most vibrant part.
They really are. The source calls them the central act of Shinto worship, often tied to the farming cycle or local history. They're about giving thanks to the kami, but also really strengthening community bonds.
A lot are held on weekends now, I suppose, so more people can join in.
Makes sense. New Year, Shogatsu, is huge.
Yeah.
Millions visit shrines for Hatsumura, the first visit of the year, buying new charms for good luck in the year ahead.
Festivals often have lively processions, Yutretsu, where the local kami is carried around in a portable shrine, a mikoshi.
Yes. And the material mentions these can get pretty boisterous, sometimes fueled by a bit of sake, Creates this sort of carnivalesque atmosphere that's seen as regenerative for the community spirit.
Shinto also marks key life moments through rites of passage.
Mm-hmm. Like the Hatsumiyamari, that's when a baby, about a month old, is taken to the shrine for the first time, presented to the local kami, gets blessings.
Coming-of-age ceremonies, too, and weddings, shinzen kekkon, are often held at shrines now.
Yes, although it's striking, as the source puts it, that most Japanese are still born Shinto, yet die Buddhist.
Meaning Shinto handles births and marriages, but funerals are overwhelmingly Buddhist.
Exactly. That's linked back to that taboo around death, kigari. Death imparts impurity in Shinto thinking.
So even for historical figures who became kami, like Hachiman, their actual physical remains aren't kept at the shrine.
Correct, because of the impurity associated with death. Shinto funerals themselves are pretty rare now, mostly for priests or members of certain sects.
Lastly, the source touches briefly on spirit mediumship and healing.
Yeah, the idea that a kami can temporarily possess a person and speak through them kami-gakari, this has been influential, especially in founding some of Japan's new religious movements.
It specifically mentions Itako or Ichiko, blind women in northern Japan trained as mediums.
Right, they mediate between the living and the spirits of the dead, often operating outside the official shrine system.
Okay, looking back at the history then, the tradition really emerged from prehistoric Japan. Kami worship goes way back to the Yayoi period.
A really pivotal moment was Buddhism arriving around the 6th century in the Kofun period.
But it wasn't so much conflict, more integration.
Much more integration. It led to Shinbutsu Shugu, this deep intertwining of kami worship and Buddhism that lasted for centuries. Kami were often seen as protectors of Buddhism, or even as manifestations of Buddhas or bodhisattvas.
There was an early attempt to organize things institutionally. The Jingyakan.
Yes, mid-7th century, a government council for kami affairs. Some see that as a key step towards a distinct Shinto structure, focusing on state rituals to unify the country through kami reverence.
Okay, fast forward quite a bit to the Meiji Restoration in 1868. The source calls this the formative years of modern Shinto.
Definitely. It was fueled by this resurgent nationalism, a desire to elevate indigenous traditions over Buddhism, which some saw as foreign influence.
So the Meiji government forcibly separated kami worship from Buddhism, Shinbutsu Bunri.
They did, often quite destructively, removing Buddhist elements from shrines. And they set up this state-controlled system of shrines and priests, culminating in state Shinto.
And in that era, shrine worship was actively used to promote loyalty to the emperor,
who was promoted as a living kami, an arahitogami. It got very deeply tangled up with national ideology and, ultimately, militarism.
But that state Shinto system was dismantled after World War II.
Yes. During the U.S. occupation, the new constitution brought in religious freedom, separated religion and state. The emperor himself publicly stated he wasn't divine.
Which ended state funding for shrines, but also gave them back their autonomy.
Right. And in the post-war era, many shrines formed the Association of Shinto Shrines, Jinjahanshu. There were, and still are, ongoing debates about Shinto's role in wartime militarism, legal challenges about public officials participating in religious rites. It's complex.
And finally, the source notes Shinto themes have influenced many of Japan's new religious movements.
And aspects of Shinto have spread globally, too, through emigration and some conversion, maybe attracting interest partly because it doesn't have such a rigid dogma.
It's clear the picture of who is Shinto is complicated. Official stats might show huge numbers participating in activities.
But surveys show only a small minority actually identify exclusively as Shintoists.
Which brings us right back to the beginning, doesn't it?
It does. It's often more about cultural participation, about practice, that connection to place and community, rather than signing up to a specific creed or label.
So that was our deep dive into Shinto, guided by that really interesting source material. We've covered a lot from the fluid idea of kami to the deep focus on purity and ritual action.
And tracing that complex history intertwined with Buddhism, with the state, ups and downs.
We've definitely seen it's not one single thing, but this really diverse collection of practices connecting people to local places, family traditions, maybe national identity too.
Understanding Shinto really does give you a unique lens on Japanese culture, doesn't it? Art, daily life.
Yeah, it helps make sense of symbols you see everywhere, like the torii, explains maybe the cultural emphasis on cleanliness. It reveals this worldview where the sacred isn't separate, it's right here, in the world, in nature, in human actions, all striving for harmony.
It gives you insight into a perspective where the phenomenal world itself is seen as divine, and where that connection to environment, to community, is just paramount.
So as you think about all this, here's a final thought to maybe chew on. How does a tradition like this one with, as the source says, no single creator or specific doctrine, where divinity itself is fluid, where humans can even become divine, how does it manage to persist?
Yeah, and adapt and stay so central to a culture through centuries of massive change, external influences. What does that tell us?
What does that fluidity, that focus on practice, tell you about belief itself, about identity, about our fundamental connection to the world around us?
Something to ponder.
Definitely. Thanks for joining us on this deep dive.
Okay, let's unpack this. We're diving into something truly mysterious today. Something that makes up the vast majority of the universe's mass, yet remains stubbornly invisible to us. We're talking about dark matter.
That's right. And our guide for this deep dive, it comes from a really comprehensive online encyclopedia entry, a deep exploration of, well, everything we think we know about this cosmic enigma.
Our mission, to take this stack of information and kind of cut through the complexity, pulling out the most important insights, the surprising facts, basically the things that give you a real shortcut to understanding this fundamental cosmic mystery and why scientists are so convinced it's actually out there.
The central question we're wrestling with is, simple on the surface, but the answer is far from it. What is dark matter, and what makes the scientific community so sure it's shaping the cosmos around us?
So let's start with the basics then. What is this invisible stuff we call dark matter?
Well, based on the source, you can define it as a hypothetical form of matter that doesn't interact with light or any other electromagnetic radiation. Essentially, we can't see it. We can't feel it with light-based instruments. Yeah. It doesn't emit, reflect, or absorb light at all.
Invisible. Okay, that's the key difference from, well, everything we experience day to day. But its existence isn't just a guess, is it? It's not just, well, maybe.
Not at all. No, its presence is implied purely by the gravitational effects it has on visible matter, on stars, on gas, and even on light itself. When you look at how galaxies spin or how clusters of galaxies hold together or, how light bends as it travels through space.
Right.
The gravity we observe is just far, far stronger than what can be explained by the visible stuff alone, the stars, the gas, the dust, if you assume general relativity is correct on those scales.
And we're not talking about just a little bit of missing mass, are we? This isn't like a small observational error or something.
Hardly. In the standard model of cosmology, which we call the lambda-CDM model, the universe's total mass energy budget is roughly 5% ordinary baryonic matter. That's stuff you and I are made of. Stars, planets, gas.
The normal stuff.
The normal stuff. Then about 26.8% dark matter, and the rest, about 68%, is dark energy. So just think about that. Dark matter is about 85% of the total mass in the universe.
85% of the mass. That's staggering. So the ordinary matter we actually see is just like the tip of the iceberg, gravitationally speaking.
Exactly. It completely dominates the gravitational landscape, and it's thought to be absolutely crucial for structure formation. We think it acts like a kind of gravitational scaffolding, pulling ordinary matter together over cosmic time to form the cosmic web of galaxies and clusters we see across these vast scales.
But because its main interaction seems to be just gravity, maybe, possibly, a tiny bit through the weak force, detecting it directly, like here on Earth in a lab, becomes incredibly challenging, right?
Yeah.
It just passes right through normal matter.
Pretty much. Yeah, that's the difficulty.
Now, this whole idea, needing extra unseen mass to explain how things move in the cosmos. It isn't a brand new concept that just popped up recently, is it? It actually has a surprisingly long history.
It really does. You can go all the way back to the late 19th century.
Yeah.
Lord Kelvin, in 1884, he was one of the first to sort of infer the existence of dark bodies near the sun based on how nearby stars were moving.
And even the term itself isn't modern. You mentioned Henri Poincaré used matière obscure, dark matter, way back in 1906.
That's right. And then later in the 1920s and 30s, astronomers like Jacobus Kapteyn and Jan Oort also noticed suggestions of extra unseen mass right here in our own galaxy. Though their initial estimates were more tied to the galactic plane, not quite the huge halo we think of now.
But the real turning point, the observation that kind of kicked off the modern hypothesis, that often gets attributed to Fritz Zwicky in 1933, he was looking at the Coma cluster of galaxies.
Yeah, Zwicky. What he did was pretty clever. He used something called the virial theorem. It basically relates the kinetic energy, how fast things are moving, to the potential energy, the gravity holding them together in a stable system.
Okay.
So he looked at how fast the individual galaxies were zipping around inside the Coma cluster. Then he estimated the cluster's total mass based purely on its brightness, essentially, just adding up the light from all the visible stars and gas in those galaxies.
And what was the comparison? What did he find?
Well, the galaxies were moving so fast, based on their visible mass alone, the cluster should have just flown apart ages ago. To keep them gravitationally bound, he calculated there needed to be vastly more mass present than he could see. His initial estimate was actually about 400 times more.
Wow.
Which turned out to be high. The number was off, but his key conclusion was absolutely correct. Most of the mass in that cluster had to be invisible or dark.
So that was looking at huge clusters of galaxies. What about individual galaxies like our own Milky Way or Andromeda?
Right. That was the next key piece of the puzzle. It started emerging in the late 1930s with H.W. Babcock looking at Andromeda, but it was really refined significantly in the 1970s. This is where people like Vera Rubin and Kent Ford come in, doing crucial optical observations. And also radio astronomers who could look at hydrogen gas using the 21-centimeter line much further out from the galactic center than visible stars.
And what was so surprising about those rotation curves, the plots of speed versus distance?
You'd expect, right? Just like planets orbiting the sun. Stars and gas further out from the galactic center, where most of the visible mass seems to be concentrated, should orbit slower. The speed should drop off with the distance, following Kepler's laws.
Makes sense.
But they consistently found that the rotation speeds remained high, or even slightly increased, way out into the galactic disk and beyond, far from the bright center. They were flat, not declining.
It's like finding out Pluto orbits the sun just as fast as Mercury. That's completely counterintuitive if you only count the mass you can see.
Exactly. That flat or rising rotation curve is incredibly powerful evidence that there's a huge amount of unseen mass distributed way out in a vast halo around the galaxy, extending much, much further than the visible light does. Albert Bosma's really detailed work in 1978 provided very strong evidence for this.
And around the same time, the theoretical picture started shifting too, didn't it? People started thinking about what this stuff could be made of.
Yes, exactly. In 1978, there was a key paper by Stegman and colleagues. They explored the idea that this dark matter could be made of a new type of particle, something stable, electrically neutral, that interacts only very, very weakly with normal matter. This basically set the stage for the concept of WIMPs.
WIMPs, weakly interacting massive particles.
Right. So by the late 70s, early 80s, the idea of these extensive dark matter halos around galaxies was becoming widely accepted, really propelled by these converging lines of evidence from galaxy rotation curves and cluster dynamics.
Okay, so we had these early hints, then strong evidence building through the 70s, and then from the 1980s onwards, it seems like the floodgates opened. A wealth of observational evidence across vastly different cosmic scales just made the case for dark matter incredibly compelling.
Yeah, this is where the picture really snaps into focus. It's not just one or two observations anymore. It's evidence piling up from all directions using completely different methods. It becomes really hard to ignore. Let's maybe run through some of the most powerful examples.
Okay, yeah. Let's start with those flat galaxy rotation curves we just talked about. That's still fundamental evidence, right?
Absolutely. Found in essentially all spiral galaxies we look at closely, they clearly show that the distribution of mass in galaxies does not match the distribution of visible light. There's much more mass further out.
And the same basic principle applies to elliptical galaxies and even smaller things like globular clusters, right? But you measure it a bit differently there.
Yes. In those systems which don't have organized rotation like spirals, you look at velocity dispersions. That's basically how fast the stars are randomly moving around within the system. You use the virial theorem again, and you find they're moving faster, buzzing around more energetically than the visible mass alone should allow, again suggesting hidden mass holding them together.
Okay, moving up in scale. Those galaxy clusters Wiki first studied, they're still key laboratories.
Oh, they are the best laboratories for studying large amounts of dark matter. And what's really incredible now is that you can estimate their total mass in at least 3 completely independent ways.
Okay, what are they?
1, you measure the speeds of the individual galaxies orbiting within the cluster, just like Zwicky did, but with much better data. 2, you measure the temperature and distribution of the extremely hot gas that fills the space between galaxies in the cluster. This gas is trapped by the cluster's gravity, and its properties tell you how deep that gravitational well is. You observe it via the X-rays it emits.
X-rays from hot gas.
Okay.
Okay, and the third way,
Gravitational lensing. You measure how the cluster's immense mass bends and distorts the light from galaxies located far behind it. The amount of bending tells you the total mass doing the bending.
Do these three very different methods, galaxy motions, hot, gas, X-rays, light bending, do they agree?
They agree remarkably well, which is amazing, really. And they consistently show that the total mass in these clusters is roughly 5 times larger than the mass you can account for from the visible galaxies and the hot gas combined. That missing 5/6, that's the dark matter.
Wow. Okay, speaking of galaxy clusters and gravitational lensing, the bullet cluster collision often gets brought up. It's sometimes called the smoking gun evidence. What makes that one so special?
Yeah, it's often called direct empirical proof because you literally see the dark matter separating from the ordinary matter during this collision. What you have is 2 galaxy clusters that have smashed into each other and passed right through. Now, using gravitational lensing, astronomers mapped where the bulk of the mass is located in this colliding system. And that map shows the mass concentrations passed right through the collision largely unimpeded. That's inferred to be the dark matter because it only interacts gravitationally, not through friction or drag.
But where's the gas? The normal, visible matter.
Well, the vast clouds of superheated gas within the 2 clusters, which is most of the ordinary matter, definitely interacted electromagnetically as they collided. Think of it like friction or drag. So the gas clouds got slowed down, shocked, and are now visibly lagging behind the main concentrations of mass seen by lensing.
So the dark matter just sailed through almost like ghosts, while the normal gas got stuck in the middle, slowed down by the collision. That visual separation, that seems really hard to explain without dark matter.
Precisely. It presents a huge challenge for theories that try to explain galactic motions simply by modifying the laws of gravity. Here, it looks very, very much like there's an extra substance involved, one that doesn't interact electromagnetically.
And gravitational lensing itself, not just in the bullet cluster, but just generally looking across the universe, that's become a really powerful tool for mapping this stuff, hasn't it?
Absolutely. Mass bends space-time, and light follows space-time. So by observing how the light from very distant background galaxies is distorted by the mass of closer objects, whether it's strong lensing, creating those dramatic arcs in multiple images you sometimes see, or weak lensing, causing subtle statistical distortions in the shapes of thousands of background galaxies, we can directly map the distribution of mass.
And those maps?
Those maps consistently show large clumps and filaments of mass where there isn't nearly enough visible matter to account for the lensing effect. The distribution aligns beautifully with what computer simulations predict for the distribution of dark matter in the cosmic web.
Okay, zooming out even further to the largest possible scales. Even the overall composition and evolution of the entire universe seems to demand dark matter.
Yes, absolutely. Observations of Type Ia supernovae, which act as reliable standard candles across cosmic distances, allowed us to measure the expansion history of the universe very precisely. They revealed 2 astonishing things in the late 90s. The universe's geometry is almost perfectly flat, and its expansion is actually accelerating.
Right, accelerating due to dark energy.
Exactly. But the flatness part is key here, too. A flat universe implies a specific critical density of total mass and energy. When you measure the contribution from dark energy, which drives the acceleration about 68%, and the contribution from ordinary baryonic matter, stars, gas, us, about 5%.
There's a big chunk missing.
There's a big chunk missing. About 27% of the total density needed for flatness must be made of something that clumps gravitationally like matter but isn't ordinary baryonic matter. This missing component is the dark matter component required to balance the universe's energy budget.
And perhaps the most precise and compelling evidence of all comes from the cosmic microwave background, right? The CMB, the afterglow of the Big Bang.
The CMB is just incredible. The pattern of tiny temperature fluctuations, those little hot and cold spots in the CMB radiation across the sky, measured with exquisite precision by satellites like WMAP and especially Planck. This pattern is one of the cornerstones of modern cosmology.
And how does dark matter fit in?
That pattern, the specific sizes and strengths of those spots, can be predicted theoretically by our standard cosmological model, lambda CDM. But that model only works and fits the observed data with such stunning accuracy if dark matter is included as a major component from the very beginning.
Why is dark matter essential for that CMB pattern? What does it do?
In the very early universe, before atoms formed, ordinary matter, protons, electrons, was tightly coupled to photons, to radiation. This photon baryon fluid was very hot and dense. Density fluctuations in this fluid couldn't really grow much because the intense radiation pressure pushed back creating sound waves, actually. But dark matter, crucially, doesn't interact with photons. So, clumps of dark matter could start to grow gravitationally much earlier, even when the universe was still dominated by radiation. These early dark matter clumps created gravitational potential wells.
Like little dips in spacetime.
Exactly. They formed the initial gravitational seeds. Later, after the universe cooled enough for neutral atoms to form and decouple from radiation, which is when the CMB was emitted, the ordinary matter could then fall into these pre-existing dark matter potential wells.
Ah, so dark matter provided the scaffolding for structure to form later on.
Precisely. This is absolutely crucial for structure formation. Without those early dark matter clumps acting as gravitational anchors, the tiny fluctuations we see imprinted on the CMB in ordinary matter would have been largely washed out by radiation pressure. There simply hasn't been enough time since the Big Bang, about 13.8 billion years, for gravity acting on only the ordinary 5% of matter to form the vast galaxies, clusters, and cosmic web structures we observe today. Dark matter provided the necessary gravitational kickstart and dominates the structure formation process.
Okay, one more piece of large-scale evidence. Baryon acoustic oscillations, or BAO. What are those?
So those sound waves I mentioned in the early Phaeton baryon fluid, they traveled outwards from initial density peaks until the universe became neutral and the waves effectively froze in place. This left behind a characteristic imprint.
Like ripples on a pond.
Sort of. It left a slight preference for galaxies to be separated by a particular distance, about 500 million light years today, which corresponds to how far those sound waves traveled before freezing. This preferred separation scale acts like a standard ruler etched into the large-scale distribution of galaxies.
And we can measure this ruler.
Yes, large galaxy surveys like the Sloan Digital Sky Survey, SDSS, and the 2DF Galaxy Redshift Survey have measured this BAO scale very precisely by mapping the positions of millions of galaxies. Combining these BAO measurements with the CMB data provides incredibly tight constraints on cosmological parameters like the total matter density and the baryon density. And those constraints strongly confirm the need for dark matter, consistent with the amounts inferred from the CMB and supernovae.
Wow. Okay, so rotation curves, velocity dispersions, cluster masses from 3 different methods, the bullet cluster separation, gravitational lensing maps, the universe's overall composition, the CMB pattern, structure formation history, and BAO, that is. That's a lot of converging evidence from completely different areas of observation.
It really is. That's why the vast majority of astrophysicists and cosmologists are convinced that dark matter in some form must exist. The gravitational evidence is just overwhelming across all scales.
Right, so we have all this overwhelming evidence that it's there gravitationally. But the next absolutely burning question is, what is it actually made of?
That's the million-dollar question, or maybe billion-dollar question, given the experiments. It's what particle physicists and astrophysicists are actively trying to figure out right now. We know that it is, but we don't know what it is.
Could it just be, dark versions of normal stuff we already know about, maybe lots and lots of black holes or really faint burnt-out stars, or just cold gas clouds we can't easily see? Things sometimes called machos, massive compact halo objects.
That was an early thought, yeah. Could the dark matter just be ordinary baryonic matter that's just hard to detect? While some of those things definitely exist and contribute some amount of dark mass.
Not enough.
Not nearly enough. The evidence strongly points away from them being the majority of dark matter. First, there's Big Bang nucleosynthesis, BBN. This theory very accurately predicts the abundance of light elements like hydrogen, helium, lithium that were forged in the first few minutes after the Big Bang. The success of BBN places a very tight constraint on the total amount of ordinary baryonic matter the universe can contain. It puts it at about 4 to 5% of the critical density.
And we need about 30% total matter density.
Exactly. So BBN tells us most of the matter cannot be baryonic. Plus, those dedicated searches for machos using gravitational microlensing where you look for the temporary brightening of a background star as a massive dark object passes in front of it.
Did they find any?
They found some, consistent with expectations for known stellar remnants like white dwarfs, but nowhere near enough objects, especially in the mass ranges needed, to explain the vast amount of dark matter required in galactic halos.
Okay. And you mentioned the CMB analysis earlier also points to most matter being non-baryonic.
Yes, the precise shape of the peaks in the CMB power spectrum is sensitive to both the total matter density and the baryon density. The analysis confirms that about 5/6 of the total matter density must be non-baryonic. It's not made of protons and neutrons like us and the stars.
So it's likely something entirely new, something exotic, something not in our current standard model of particle physics. What are the leading theoretical candidates scientists are pursuing them?
Historically, for a long time, the prime candidate was the weakly interacting massive particle.
Okay, wimpy and EDAT. Weakly interacting massive particle. The name pretty much describes what it's supposed to do, right? Interact weakly and have mass.
Right, interact via gravity and possibly the weak nuclear force, but not the strong force or electromagnetism, which is why it's dark. And there was this really compelling idea called the WIMP miracle.
The WIMP miracle. What's miraculous about it?
Well, the thought was this. If you hypothesize a new particle with a mass roughly around 100 times the proton mass, so 100 GeV or so, and interaction strengths typical of the weak nuclear force, and you calculate how many of these would naturally be left over from the thermal soup of the very hot early universe.
Yeah.
It turns out you naturally get just about the right abundance, the right density, to explain all the dark matter we observe today. This seemed like a remarkable coincidence. It suggested that perhaps physics at the weak scale, which we know exists, was tied to the dark matter mystery.
And these WIMPs were predicted by some theories beyond the standard model.
Yes, particularly theories like supersymmetry, SUSY, which predict partner particles for all the known standard model particles. The lightest supersymmetric particle was often a perfect WIMP candidate, stable, massive, and weakly interacting. So WIMPs were very attractive theoretically for a long time.
But we haven't actually found them, have we? Despite looking really hard.
Exactly, that's the rub. Decades of increasingly sensitive direct detection experiments have searched for WIMPs bumping into atomic nuclei, and they haven't found convincing evidence. Also, the Large Hadron Collider hasn't found strong evidence for simple supersymmetry or other physics that would naturally produce WIMPs.
So the enthusiasm for the simplest WIMP models has cooled a bit.
It has. It doesn't mean WIMPs are ruled out entirely. The parameter space is large, but they're perhaps not the shoo-in candidate they once seemed, which has naturally led to increased interest in other possibilities.
Like axions.
Axions. Okay, what are they? Axions are another type of hypothetical particle, but they are very different from WIMPs. They are predicted to be extremely light, potentially billions or trillions of times lighter than an electron. They were originally proposed back in the 70s to solve a completely different problem in particle physics.
Oh, not for dark matter initially.
No, they were proposed to solve something called the strong CP problem within the theory of the strong nuclear force, quantum chromodynamics, QCD. But it turns out that if axions exist and have the specific, very tiny mass somewhere in the microelectron volt to picoelectron volt range, they could have been produced non-thermally in the early universe in vast numbers, enough to constitute the cold, dark matter.
And they've gained popularity recently.
They have, partly because the lack of WIMP detection has encouraged looking elsewhere, and partly because they naturally fit the cold, dark matter picture they'd be moving very slowly today, despite their tiny mass. There's a big experimental push now to try and detect axions.
Okay, WIMPs, axions.
Huh?
What about those primordial black holes, PBHs, we touched on briefly?
Right, PBHs. These are hypothetical black holes that could have formed very shortly after the Big Bang, not from collapsing stars, but from the collapse of very dense regions in the primordial plasma itself.
So they aren't limited to stellar masses, and they aren't technically baryonic in the same way?
Exactly. They could potentially have a very wide range of masses, from asteroid mass up to thousands of solar masses, and crucially, because they formed before Big Bang nucleosynthesis, they don't count towards that BBN limit on baryonic matter. They are made from the energy density of the early universe itself.
What's the appeal of PBHs?
Well, the main appeal is they don't require new physics beyond the standard model in general relativity. We know black holes exist. The question is just whether they could have formed in the early universe in sufficient numbers. They got a boost in interest after LIGO started detecting mergers of intermediate mass black holes, which might potentially be primordial.
But are there constraints?
Yes, quite strong ones. Gravitational microlensing searches, looking for smaller PBHs, have ruled them out as the dominant form of dark matter across many mass ranges. There are still some possible mass windows open, particularly very small ones or very large ones, but it's debated whether they could make up all of the dark matter.
And scientists also classify these theoretical candidates by how fast they were moving in the early universe, right? Cold, warm, hot.
That's right. It's based on their velocity back when structures started forming. It affects how easily they could clump together. Hot dark matter particles, like standard neutrinos, were moving close to the speed of light. Their fast motion would tend to wipe out small density fluctuations, meaning large structures would form first, then fragment.
But that's not what we see.
No, Observations, like from the Hubble Deep Field, show that small galaxies and structures formed first and then merged over time to build larger ones. This is called hierarchical structure formation, and it strongly favors cold dark matter, CDM particles, that were moving slowly when structure formation began. WIMPs and axions are both typically considered cold dark matter candidates. Warm dark matter is intermediate and still debated. Hot dark matter, like neutrinos, can only be a very small fraction of the total dark matter.
Okay. And just to circle back, the alternative to adding any new particle, modifying gravity.
That idea is still out there, yes. Some physicists explore whether our understanding of gravity itself, usually Einstein's general relativity, might need modification on galactic or cosmic scale. Perhaps there is no dark matter, and the effects we attribute to it are really just gravity behaving differently over large distances.
And specific theories like MOND, modified Newtonian dynamics.
MOND has had some success, particularly in explaining the flat rotation curves of spiral galaxies without needing dark matter halos. It modifies gravity's strength in regions of very low acceleration, like the outskirts of galaxies.
But can theories like MOND explain all the evidence we've discussed? The clusters, the lensing, the CMB, the large-scale structure?
Not currently, no. That's the major hurdle. While MOND works well for galaxy rotation, it struggles significantly to explain the dynamics of galaxy clusters, the observations of the bullet cluster collision, the precise pattern of the CMB fluctuations, and the large-scale structure formation traced by BAO without invoking some form of unseen matter, often resembling hot dark matter like neutrinos, which we know isn't enough.
So no single modified gravity theory has yet managed to successfully explain the full range of observational evidence simultaneously. The prevailing view remains that the evidence points much more strongly towards the existence of some form of non-baryonic dark matter particle. Okay, so if dark matter is likely some kind of particle that interacts mainly through gravity, maybe weakly, and it's literally all around us, filling the galaxy, how on earth do we actually try to find it, detect it?
Yeah, this is a massive, ongoing, global scientific effort. And you put your finger on the core challenge. How do you detect something that barely interacts? Think about it. If dark matter is, say, WIMPs, billions of these particles could be streaming through your body through the entire Earth every single second without leaving hardly any trace.
That's still kind of a mind-boggling thought, billions passing through us right now. Okay, so how do you try to catch one of these elusive particles? What are the strategies?
There are basically three main experimental approaches scientists are pursuing. The first is called direct detection.
Direct detection.
Yeah.
Trying to actually sense it bumping into something here on Earth.
Exactly. The idea is to build incredibly sensitive detectors, usually deep underground in old mines or tunnels, to shield them from cosmic rays and other background radiation that could mimic a signal.
Okay, what are these detectors made of?
Typically, they use large volumes of very pure material as a target. Common examples are tanks filled with liquefied noble gases like xenon or argon, or arrays of ultra-pure crystals like germanium or silicon, cooled to extremely low temperatures near absolute zero.
And the hope is?
The hope is that one of the billions of dark matter particles passing through the detector will occasionally, very rarely, bump into an atomic nucleus in the target material. This collision would cause the nucleus to recoil slightly, depositing a tiny amount of energy.
Tiny amount.
Incredibly tiny. So the detectors are designed to sense this minuscule energy deposit, perhaps as a flash of light, scintillation, or a release of electric charge, ionization, or a tiny rise in temperature.
Phonons. And have these extremely sensitive experiments found anything conclusive yet?
It's been a very challenging search, pushing technology to its limits. There's one long-running experiment called Demolibra using sodium iodide crystals that has reported observing an annual modulation, a signal that peaks in June and troughs in December, which is what you might expect as the Earth moves through the galaxy's dark matter halo faster in the summer.
Interesting.
But, and it's a big but, most other larger, arguably more sensitive experiments using different targets and techniques like the LUX and now LZ experiments, the Xenon experiments, PANDAX, they have not confirmed this signal. They've searched for similar interactions and found nothing, setting very strong upper limits on how strongly WIMPs, at least simple WIMPs, can interact with normal matter.
So the gamma signal remains controversial and unexplained. Overall, direct detection hasn't yielded a definitive discovery yet, though the search continues with even bigger and better detectors. Okay, so that's direct detection trying to feel it hit something directly.
Yeah.
What's the second main approach?
That's indirect detection. Here, instead of looking for dark matter particles hitting a detector, we look for the products of dark matter interactions happening out in space.
How would that work? What kind of products?
Well, if dark matter particles can annihilate with each other when they meet, or if they are unstable and decay over long timescales, they might produce standard model particles that we can detect. For example, they could produce high-energy photons, gamma rays, or pairs of particles and antiparticles like electrons and positrons, or protons and antiprotons, or even neutrinos.
So you look for an excess of these standard particles coming from regions where you expect dark matter to be very dense.
Exactly. Places like the center of our Milky Way galaxy or the centers of nearby dwarf galaxies, which are thought to be very rich in dark matter, or even galaxy clusters. You use telescopes, gamma-ray telescopes like Fermi and HESS, cosmic ray detectors on satellites like Pamela and AMS, or neutrino telescopes like IceCube at the South Pole to search for an unusual excess of these potential dark matter signals above the expected background from normal astrophysical processes.
And have these indirect searches found anything promising?
There have definitely been some intriguing hints and anomalies. For instance, the Fermi telescope has seen an excess of gamma rays coming from the galactic center around a certain energy range. AMS has confirmed an excess of positrons in cosmic rays at high energies.
Could that be dark matter?
It could potentially be from dark matter annihilation or decay. However, the big challenge with indirect detection is distinguishing a potential dark matter signal from conventional astrophysical sources. For example, rapidly spinning neutron stars, called pulsars, can also produce gamma rays and positrons, and it's currently very difficult to definitively rule out pulsars or other astrophysical explanations for these observed excesses. So like direct detection, indirect detection has yielded intriguing clues, but no smoking gun discovery yet.
Okay. Direct detection tries to catch them here. Indirect detection looks for their debris out there. What's the third main method?
The third approach is collider searches, primarily at the Large Hadron Collider, LHC, at CERN near Geneva. Here, the idea is not to detect existing dark matter particles, but to actually produce them in high-energy collisions.
Create dark matter in a lab. How?
By smashing particles, usually protons, together at extremely high energies. According to Imsi Balassir, that energy can be converted into mass, potentially creating new, heavy particles predicted by theories beyond the standard model, including, possibly, dark matter particles.
But if dark matter particles interact so weakly, how would you even see them if you created them in the LHC detectors? They'd just fly out undetected, wouldn't they?
Exactly. You wouldn't see the dark matter particles themselves directly in the detectors, like ATLS or CMS. Instead, you'd look for their signature indirectly, as missing energy and missing momentum.
Missing energy. How does that work?
Imagine you collide two protons head-on. You know their initial energy and momentum, which is zero transverse momentum. When they collide, they produce a shower of other particles that fly out into the detector. You carefully measure the energy and momentum of all the detectable particles produced, electrons, photons, jets of hadrons, etc. If the collision also produced a pair of stable, weakly interacting dark matter particles, they would escape the detector without interacting, carrying away energy and momentum.
So you'd see an imbalance. The energy and momentum of the stuff you do see wouldn't add up to the initial energy and momentum.
Precisely. You'd observe an event where, for example, there's a visible particle or jet recoiling against nothing. That nothing represents the missing momentum carried away by the invisible dark matter particles. This missing transverse energy signature is a key way experimenters at the LHC search for evidence of particles like WIMPs.
Has the LHC found any evidence for dark matter production this way?
So far, the LHC has not found any definitive evidence for dark matter particle production. It has placed strong constraints on the properties of many theoretical models, including various forms of supersymmetry that predict WIMPs. But like the other methods, no discovery yet. And importantly, even if the LHC did see a missing energy signal consistent with dark matter, it would ideally need to be corroborated by a signal from direct or indirect detection experiments to be truly convincing.
Right, you'd want to see it multiple ways. So 3 complementary approaches, direct, indirect, and colliders, all pushing the frontiers, but the mystery remains.
That's the state of play. A huge experimental effort, driven by the compelling astrophysical evidence, but the nature of dark matter itself remains elusive.
Given how fundamental and yet deeply mysterious this whole concept is, it's probably not surprising that dark matter has sort of seeped into popular culture, has it?
Oh, absolutely. The idea of an invisible, pervasive substance that shapes the entire universe. It's just naturally fertile ground for the imagination, isn't it? In science fiction especially, it often gets invoked and sometimes given powers or properties far beyond what the physics hypothesis suggests.
Like in the X-Files, I think there was an episode.
Yes. The episode Soft Light, if I recall correctly, used dark matter as a plot device, attributing some rather unusual shatter-related effects to it. And then you have Philip Pullman's His Dark Materials trilogy, where the concept of dust was explicitly inspired by dark matter seen as these elementary particles connected to consciousness.
Huh. And other sci-fi, too.
Stephen Baxter's big Zeely sequence series even features entire antagonist species, the Fatino birds, supposedly made of dark matter particles, Fatinos from supersymmetry. So yeah, it pops up quite a bit.
And sometimes the term itself just gets used metaphorically, doesn't it? For anything hidden or unseen influencing a system.
That happens too, definitely. It's kind of entered the broader lexicon as a shorthand for the unknown or unseen forces or components that are suspected to be important in complex systems, whether it's in economics, sociology, or elsewhere.
So, okay, let's try and bring this all back together then. We've gone on quite a journey here. We've traced the idea of dark matter from those very early hints of missing mass in the late 19th and early 20th centuries.
Right, through decades of mounting, converging observational evidence across just vast cosmic scales. We talked about galaxies spinning too fast, clusters of galaxies holding together when they shouldn't based on visible matter, light bending in ways that reveal far more mass than we see.
All the way to the incredibly precise patterns imprinted on the Big Bang's afterglow, the cosmic microwave background, and how the whole history of structure formation in the universe seems impossible without it.
And we've seen how all this evidence points overwhelmingly, really, to the conclusion that something like 85% of the universe's total mass is in some form that just doesn't interact with light in any significant way.
And then we explored the really difficult, but I guess exciting search for what this mysterious substance might actually be, whether it's some kind of new fundamental particle like the historically favored WIMPs, or maybe ultralight axions, or maybe even a primordial black hole.
While also touching on the alternative idea that maybe it's not a substance at all, but our understanding of gravity itself that needs revising, though current modified gravity theories seem to struggle to explain the full picture.
So despite all this truly compelling evidence for its gravitational influence everywhere we look, the fundamental nature of dark matter, it really remains one of the biggest unsolved mysteries in all of physics and cosmology today. This isn't settled science by any means. This is absolutely cutting-edge research happening right now.
Exactly. Scientists around the world are building bigger experiments, refining theories, analyzing data, trying to finally crack this puzzle.
And hopefully you, having gone through this deep dive with us, now have a pretty solid understanding of why scientists are so sure it's out there, the key lines of evidence that convince them, and the challenging multi-pronged avenues they're exploring to finally figure out what this stuff actually is.
It's a huge part of reality that we just don't understand yet.
Yeah. And here's maybe a final thought to leave you with, something that comes straight from the heart of this whole mystery. If dark matter is made of tiny, weakly interacting particles, as many theories suggest, then literally billions of them could be passing right through you, through your body, through the room you're in, every single second, without you ever feeling a thing.
Completely invisible, completely intangible to our senses, yet shaping the destiny of the universe on the grandest scales.
This deep dive has shown why we have such strong reasons to believe it's there, but that ultimate question, what is it, continues to drive some of the most ambitious and profound scientific exploration on the planet. What does it truly mean that something like 85% of the mass in our universe is still fundamentally completely unknown to us?
Welcome to the Deep Dive, where we take your sources and unpack the most important insights.
And today we're diving into a fascinating stack of sources you sent over, exploring the life, the incredible works, and really the enduring legacy of a figure whose poetry just keeps resonating across the globe, centuries later.
Yeah, our mission here is to get a handle on who Jalal al-Din Muhammad Rumi actually was, the world he lived in, and maybe try to unpack why he's still so incredibly popular today.
Oh.
We'll pull out those interesting nuggets, the surprising bits, the key moments, the core ideas, basically give you a shortcut to being really well informed about Rumi.
Exactly. We're going to draw straight from this material you shared, piecing together his historical reality and, how that connects to his universal appeal.
Okay, let's unpack this then. Maybe start with the basics. His identity, his name. It seems complicated.
It is a bit. The source is, well, one contemporary source, Feridun bin Ahmad Sipasalar, gives his full name as Muhammad bin al-Hussein al-Katibi al-Balkhi al-Bakri. Quite a mouthful.
Definitely. Tells you something, though. But he's known by other names, right?
Oh, absolutely. We know him mostly as Rumi in English, but the sources point out he's called Maulana or Maulana in Iran. That means our master.
And Mevlana in Turkey?
Mevlana in Turkey, exactly. And also Melawe or Mevlevi, which is my master. Lots of layers of respect there.
His formal name is often listed as Maulana Jalal ad-Din Muhammad Rumi. And Jalal ad-Din, what does that mean again?
The sources say it's Arabic for glory of the faith. So you see that blend right away.
And this last part's Balkhi and Rumi.
Those are nisbas, like descriptive tags. Balkhi means from Balkh, his origin, and Rumi means from Rum, which is Anatolia.
Okay, that Rumi part is interesting. How does someone born near Balkh get called Rumi? The sources explain that.
They do. It's because Anatolia, where he lived much of his life, was part of the old Byzantine or Eastern Roman Empire. Even after it became part of the Seljuk Sultanate, Arabs, Persians, Turks, they still called the region Rum.
Ah, so Rumi just meant from Anatolia or associated with Anatolia.
Pretty much, yeah. From the land of the Romans, essentially.
Got it. Okay, so birthplace and date. Let's nail that down from the sources.
The date is specific, 30 September 1207, the birthplace. There's a slight ambiguity in the sources, either Balkh in modern Afghanistan or Wakhash in modern Tajikistan.
Oh, wash.
Yeah, the source notes Wakhash was a village near Balkh where his father was a preacher. Culturally, it was very much part of the greater Balkh region, which was a huge center of Persian culture then.
And his parents.
Persian parents. His father was Bahauddin Walad, a big deal, known as Sultan al-Ulama, Sultan of the Scholars. His mother was Mumina Khatun, sometimes called Mami.
So a very scholarly, religious family background?
Absolutely. The sources say they came from generations of Islamic preachers, part of the Hanafi maturity school, which was seen as relatively liberal. And living in Balkh. I mean, that was a vibrant center for Persian learning and poetry at the time.
So established family, important cultural center. Why did they leave?
Yeah, that's a key point. The sources are very clear. They emigrated west because of the Mongol invasion, sometime between 1215 and 1220. This wasn't a choice. It was fleeing devastation.
And on that journey, there's that famous story mentioned in the sources, maybe legendary, about meeting the poet Attar.
Yes, the hagiographical accounts mention this encounter in Nishapur. Rumi would have been quite young, a teenager. Attar supposedly saw his spiritual depth immediately.
Isn't there a famous quote?
There is. Here comes a sea followed by an ocean. Attar referring to Rumi's father, the sea, and young Rumi as the ocean to come. The story also says Attar gave him his book, the Asranama.
Wow. Whether it happened exactly like that or not, it definitely places him in a significant lineage. Who else influenced him, according to the sources?
Besides his father and Attar, the sources really stress the poet Sanai. Rumi himself quoted them, expressing deep respect. Things like, Attar was the spirit, Sanai his eyes twain.
And in time thereafter came we in their train.
Yeah, I remember that. Exactly.
Mm-hmm.
And he also said something like, Attar has traversed the 7 cities of love. We are still at the turn of one street. Shows real humility and acknowledges their influence.
So where did this big journey take them after Nishapur?
The sources trace quite a path. Through Baghdad, down to Hijaz for the Hajj pilgrimage in Mecca, then Damascus, and across various cities in Anatolia, Malakia, Erzincan, Sivas, Kayseri, Nigde. A long way.
And they settled for a bit.
For 7 years, yeah, in Karaman. But it was a tough period, personally. The sources note his mother and brother died there.
What about Rumi's own family? Did he marry there?
Yes. The sources say he married Geuher Khatun in Karaman around 1225. They had 2 sons, Sultan Walid and Ala Eddin Chalabi. Later, after her death, he remarried and had another son, Amir Alim Chalabi, and a daughter, Malaka Khatun.
And the final stop on this journey?
Konya in Anatolia. They moved there around May 1228. The sources suggest they were likely invited by the Seljuk ruler Alauddin Kikobat. Konya was a major city, the capital of the Sultanate of Rum.
So Rum again. What was his life like when he first got to Konya?
He stepped right into his father's shoes, essentially. When Bahauddin died, Rumi took over his position as head of the madrasa, the religious school.
Was he trained for that?
Oh, yes. Very rigorously.
Mm-hmm.
The sources detail 9 years of training in Islamic law, Sharia, and the Sufi path, Tariqa, under a teacher named Sayyid Burhan Uddin Wuhakik Termazi. This went on until about 1240 or 41.
And he might have studied elsewhere, too.
Right. The sources also mention he is said to have spent 4 years in Damascus during this time, which would have exposed him to even more learning.
So he became a respected figure in Konya.
Definitely. an established Islamic jurist. The sources say he issued fatwas, gave sermons in the mosques, taught at the madrasa. By all accounts, a conventional, well-regarded religious scholar.
And then everything changes. The sources really pivot here. A single meeting transformed him.
Yes, this is the big one.
Right.
Probably the most famous event in his life, November 15th, 1244. He meets this wandering dervish, Shamsi Tabrizi, and boom.
Just like that.
Well, the impact was profound. The sources describe him changing from this accomplished scholar and jurist into an ascetic, totally consumed by the mystical path.
The sources put this in the context of Sufism, right? The master-disciple thing.
Exactly. In Sufism, that relationship is crucial for spiritual development, for reaching fana, that state of annihilating the ego and the divine. Shams became that catalyst, that mirror for Rumi.
And the story of how Shams found him is pretty striking, too.
It is. The sources tell it like Shams was traveling, looking for someone who could endure my company, someone who could handle the intensity of his spiritual presence. And a voice supposedly told him, "The one you seek is Jalal-ud-Din of Konya." Sets it up like destiny.
But this intense connection, it didn't last long in person, did it? Shams disappeared.
No, it was cut short. Tragically and mysteriously. The sources state that on the night of December 5th, 1248, Shams just vanished, never seen again.
There are theories about what happened.
Several mentioned in the sources. One is that Rumi's younger son, Ala-eddin, jealous of the relationship, killed him. Another is that others killed Shams, maybe finding his influence or teachings blasphemous.
Yeah.
Or maybe Shams, being a wanderer, just moved on.
Do the sources favor any theory?
They do add a note of caution about the son theory, saying it comes from an unreliable source. So it remains a mystery.
But Rumi's reaction was intense. Grief, searching.
Absolutely. Deep mourning. The sources say he wore black after 40 days. He searched tirelessly for Shams, even traveled back to Damascus looking for him. You can imagine the despair, losing that spiritual anchor.
And it was out of that grief, that search, that he had this incredible realization.
Yes, this is such a key moment. While searching in Damascus, the sources say, he had this breakthrough. Why should I seek? I am the same as he. His essence speaks through me. I have been looking for myself.
Wow. So he found Shams within himself?
Kind of. He realized the divine connection he felt through Shams wasn't external, but accessible within. Shams was the mirror reflecting his own potential. And this profound loss, this inner shift, it didn't silence him. It actually unleashed this incredible flood of creativity, an outpouring of poems.
Which became a major collection, right?
Right, the Divan-i Kabir, the great work, were often called Diwan-i Shamsi Tabrizi, named right after Shams. It shows you how central Shams remained. It's huge, something like 35,000 Persian couplets, 2,000 quatrains.
And the sources mention its linguistic mix, which is really interesting.
It really is. Mostly Persian, of course. But the sources point out there are poems or lines in Arabic, quite a few ghazals and quatrains. Also Turkish couplets, often mixed with Persian in what they call macaronic poems.
And even Greek?
Yeah, even Greek. About 14 couplets found in 3 macaronic poems and mixing Greek and Persian. It really reflects that diverse Anatolian world he was living in.
After Shams, he found other companions.
Yes, the sources mention Salah-ud-Din Zarkub, who's a goldsmith. And then, really importantly, Husam Chalabi, who became his scribe and a very close student.
And Husam played a key role in Rumi's most famous work, the Masnavi.
Absolutely central. The story for the sources is that Husam suggested Rumi write something more structured, like Attar or Sunai had done, a kind of spiritual guide.
And Rumi was ready?
It seems like it was just waiting to come out. The sources say he immediately pulled out a piece of paper with the first 18 lines already written, starting with that iconic line.
Listen to the reed and the tale it tells, how it sings of separation.
That's the one. And then for the next 12 years or so back in Anatolia, he dictated the rest of the Masnavi, 6 volumes, to Husam.
Can you describe the Masnavi itself based on the sources?
Sure. The full title is Manawe Manawi, Spiritual Couplets. It's massive, around 27,000 lines. Written in rhyming couplets, a specific form. Apparently the meter he used became the standard for that type of poem afterwards.
And its reputation is enormous.
Huge. The sources call it distinguished, maybe the greatest mystical poem ever. It's often called the Quran in Persian, quoting the later poet Jami. High praise.
What's inside it? What makes it so special?
It's incredibly rich. The sources describe it weaving together all sorts of things, fables, stories about everyday life, but also deep dives into Quranic interpretation, metaphysics, philosophy.
Yeah.
It's not linear. It's more like a flowing river of stories and spiritual insights.
And besides the poetry, he also has prose works. though compiled by others.
Yes, exactly. There's Fihi Mafihi in it. What's in it, usually called the Discourses, is a collection of about 71 talks or lectures he gave, written down by his students. The sources note the style is more conversational, maybe aimed at a broader audience.
Different from the poetry.
Very different. More direct instruction, less ecstatic language. Then there's Majal Saba, the 7 sessions. These are more formal sermons.
What are they about?
According to the sources, they explore the deeper meanings of the Quran and Hadith. He quotes poets like Sanai and Attar, even his own poetry. They show his scholarly side, his knowledge of Islamic sciences.
And letters, too?
Yes, the Makatib, or the letters. These are actual letters he wrote in Persian to disciples, his family, local leaders, statesmen. The sources say these are written in a much more sophisticated, formal style than the discourses. Shows him engaging with the world, offering guidance. Okay, let's dig into the core of his teachings, his religious perspective, as the sources lay it out. The absolute center seems to be love. This all-encompassing love.
And the sources connect this strongly to his Islamic background.
They do. While his message feels universal, the sources root his teachings in Islamic tenets, particularly referencing a key verse from the Quran, 47.19. Know that there is no God but He, and ask forgiveness for your sin.
And how did Shams, or Rumi building on Shams, link that verse to love?
It's interesting. The sources explain Shams saw the first part, knowing God's oneness, Tawhid, as about knowledge. The second part, seeking forgiveness, he thought as negating your own separate self. Rumi then takes this idea of Tawhid, oneness, and explicitly links it to love. He describes love as this flame that burns away everything except the everlasting beloved.
So love is the force that dissolves the ego.
That's the idea, is the path to realizing that oneness. It speaks to a journey, a kind of spiritual evolution.
Like in that famous poem.
Exactly. The sources bring up that poem. I died to the mineral state and became a plant. I died to the animal state and became a man. It paints this picture of ascending through stages of being, dying to the lower to reach the higher, ultimately aiming for union with the divine.
And how did he describe this love?
The sources quote him. The lover's cause is separate from all other causes. Love is the astrolabe of God's mysteries. So it's not just an emotion, it's a tool, a guide for navigating the spiritual path.
This intense focus on love led him to embrace practices like music and dance, right? Which wasn't typical for all scholars.
Right. He passionately believed music, poetry, and dance were valid paths to God. The sources suggest that for him, music especially could help devotees focus so intensely that the ego gets, well, spiritually destroyed and the soul resurrected in God's presence.
And that's the origin of the whirling dervishes, the Sama ceremony.
Precisely. That practice became formalized and is the heart of the Mevlevi order he inspired. The sources describe the Sama in Mevlevi tradition not just as dance, but as a whole mystical journey ascending through mind and love, letting go of the ego and returning to serve creation.
His favorite instrument was the ney, the reed flute.
Yes, that haunting sound. The sources say the ney was his favorite, its cry, symbolizing the soul's separation from the divine source, just like in the Mesnavi's opening, though he apparently also played the robab.
Okay, so let's talk about his overall religious outlook. The sources show him clearly rooted in Islam, but there are those famous universalist quotes. How do the sources handle that?
It's presented as complex, not necessarily contradictory for him. The sources strongly emphasize his commitment to Islam. He praises the Quran constantly, calls Muhammad the perfect example. Quotes like, I'm the servant of the Quran as long as I have life.
And the Mesnavi itself.
Yes, the Masnavi's introduction, quoted in the sources, calls it the roots of the Islamic religion, and it is the explainer of the Quran. Very explicit.
But then you get the lines about all paths leading to the same light.
Exactly. The sources include those two, traces of pluralism, the idea that the core truth is one even if doctrines differ. The famous, the lamps are different, but the light is the same. It comes from beyond. Or that quatrain saying in The Seeker's Path, the Kaaba and House of Idols are one.
So how do the sources suggest reconciling this?
They seem to present it as layered. There are quotes suggesting the light of Muhammad can reach non-Muslims like Zoroastrians, Jews, but then also quotes like, if Muhammad rips the veil open, thousands of monks and priests will tear the string of false belief, which suggests a belief in Islam's ultimate truth and power to reveal reality.
So rooted in Islam, but acknowledging sparks elsewhere.
Perhaps something like that, while ultimately seeing Islam as the most complete path. The sources also clearly identify him as a Sunni Muslim, noting he praised the first two caliphs. They do mention that later Shia authors sometimes claimed him, especially after 1501, but historically he's Sunni. And scholars like Sayyid Hossein Nasr are cited as linking his work profoundly to the Quranic tradition.
Sadly, his own journey on Earth came to an end.
Yes, in December 1273. The sources say he fell ill and even predicted his own death. He passed away on December 17th in Konya.
And his funeral was remarkable, wasn't it? Showing his reach in the community.
It really was. The sources make a point of mentioning that Konya's diverse population, including local Christians and Jews, joined the massive crowd mourning him and following his coffin. That speaks volumes about the respect he held across different groups.
Where was he buried?
Beside his father. And over his tomb, this magnificent shrine was built, the Yesil Turba, the Green Tomb. Today it's the Mavlana Museum.
And sponsored by someone interesting.
Yeah, the sources note the patron was Guju Khatun, who was a Georgian princess and a Seljuk queen. Another cross-cultural connection there.
His epitaph is so famous, sums it all up almost.
When we are dead, seek not our tomb in the earth, but find it in the hearts of men. Just beautiful. Shifts the whole idea of legacy away from the physical to the internal spiritual impact.
And his followers created the Mevlevi order to carry on his legacy.
Yes, founded almost immediately after his death in 1273 by his followers and his son, Sultan Walid. Leadership traditionally stayed in Rumi's family line in Konya. The order, with its distinctive whirling dervish ceremony, the Sama, became really well established, especially during the Ottoman Empire. There's a famous monastery in Istanbul near the Galata Tower.
And they have that incredibly welcoming invitation.
Oh yeah, the famous lines. Come, come, whoever you are, wanderer, idolater, worshipper of fire. Come even though you have broken your vows 1,000 times. Come and come yet again. Ours is not a caravan of despair. Really captures that spirit of radical inclusion people find in his work.
Now, in modern Turkey, things changed for Sufi orders.
They did. Ataturk's secular reforms in 1925 led to the closure of all the Sufi lodges, the tekks, and the orders were officially dissolved. Rumi's mausoleum was reopened, but as a state museum in 1927, not an active religious center.
But the whirling dervishes, the Sama, it didn't disappear entirely.
No, it survived. From the 1950s, the Turkish government started allowing an annual public performance in Konya. This grew into the Mevlana Festival, which climaxes on the anniversary of his death, his Urs, which they call Abe Arus, the nuptial night, signifying his union with God.
And eventually they could share it more widely.
Yes, they were allowed to travel internationally from 1974, bringing the Sama to Western audiences. And a huge recognition came in 2005 when UNESCO declared the Sama ceremony a masterpiece of the oral and intangible heritage of humanity.
He's a massive cultural icon in Turkey, even on their money for a while.
He was. The sources mention him and his tomb were on the 5,000 Turkish lira banknote from 1981 to 1994.
But maybe the most amazing part of his legacy now is just how universal it's become.
It's truly astounding. The sources list translations into so many languages: Russian, German, Urdu, Turkish, Arabic, Bengali, French, Italian, Spanish, Indian languages like Telugu in Canada. It's global.
And incredibly popular in English.
Hugely. The sources specifically mention Coleman Barks' interpretive translations, selling over 500,000 copies. That played a massive role in making Rumi one of the best-selling poets in the U.S. Think about that, a 13th century Persian mystic.
He's still vital in Iran, too, of course.
Absolutely. The sources describe him as an iconic Iranian poet. His verses are displayed publicly, used in modern music, taught in schools. He's foundational for classical Iranian and Afghan music traditions.
And there was that big anniversary recently.
Yes, his 800th birthday in 2007. UNESCO declared it International Rumi Year. Iran and Turkey held major celebrations, conferences. UNESCO even issued a special medal. Huge international recognition.
And academics are still studying him closely.
Oh yes. The sources mention things like the Maulana Rumi Review Journal, dedicated to serious scholarship on him and other figures, ensuring they get their due in world literature studies.
And his tomb in Konya.
Still a major pilgrimage site, the sources say. And not just for Muslims, people from all sorts of backgrounds visit, drawn by that universal message of love and seeking.
So we've done a real deep dive into these sources, tracing Rumi's incredible life from the scholar in a family fleeing invasion, absorbing influences, to becoming this mystic whose words on, well, love and the divine just echo across centuries and cultures.
Yeah, and you've seen how his personal story, especially that intense, life-changing connection with Shamsay Tabrizi, the grief that followed, how that just fueled this unbelievable creative explosion, complex texts, letters, but also that ecstatic, multilingual poetry.
We touched on that complex religious view. The source is showing him deeply rooted in Islam, devoted to the Quran, while also expressing this powerful universal message of love and the inner search that clearly resonates with so many different people.
And his legacy, it's not just dusty books. It's alive in the Mivlevi order, in that mesmerizing Sama ceremony, in the music he inspired, and maybe most strikingly, in the fact that poems written 800 years ago are still flying off shelves today.
What really jumps out to you from all this?
Thinking about that epitaph the sources mentioned, seek not our tomb in the earth, but find it in the hearts of men. It makes you wonder, doesn't it? Given his background, the turbulent times he lived through, and now this global reach.
Yeah.
What does that really mean about legacy? Is his enduring presence just the power of beautiful poetry, or does it point to something deeper about, I don't know, the shared human quest for meaning, for connection, that his words somehow tap into across all that time and cultural distance?
That's definitely something to think about. That's our deep dive for today. We hope this exploration has sparked your curiosity and maybe given you a richer sense of this truly extraordinary figure.